Hello everyone. In this video, we will go over planar kinetics of a rigid body, impulse, and momentum. Now, if you remember, in an earlier chapter, we covered impulse and momentum, but we didn't go over rigid body. We were just going over a particle. Now, remember from previous videos, the difference is that for a rigid body, we have a moment of inertia, ig. So let's get started. First, we have the term angular momentum, hg, which is ig omega. Now, let's say we have translation, where the body just basically is moving in one direction. There's no rotation. So we have linear momentum L equals mvg. You remember that from before, and hg equals 0. Now let's say we have a rotation about a fixed axis, something like this. Say this is O, this is the body, and it's rotating. We have the linear momentum, L equals mvg, still the same. This is g, vg. And the angular momentum, hg equals ig omega, and ho equals io omega. Now let's say we have a general case where the body is moving and rotating, so it's moving, omega, we have vg. We don't have a fixed axis or anything. We have, let's say, IC is over here. So same linear momentum, L equals mvg, angular momentum hg equals ig omega, and hic equals iic omega. Now notice, before O was the instantaneous center. Now what's the principle of momentum? So the principle of momentum, as we saw before in the earlier chapter for a particle, is the same over here. So we have mvgx plus the sum of f dt equals mvgx2. Now this is linear momentum, and we have here this term is linear impulse. Now this is going to be the force times t2 minus t1. This is equals the linear momentum as state 2. Now the same goes for the y direction and for the angular. So we have ig omega 1 plus the sum of integral t1 t2 mg dt. This term is the angular impulse equals ig omega 2. Now let's do an example that summarizes all of this chapter. Let's say we have this wheel over here, center G, outer radius 0.2, and VG as such. Let's say it's rotating omega, and now we want to know what is VG for it to get to the tip of this point, which is at 0.03 meters high. Now we want it to get to just at the tip. So first we go conservation. This is very important. Conservation of angular momentum. HA1 equals HA2. So what is H? We saw that before. It's RMVG plus IG omega. This equals RMVG2 plus IG omega 2. Now we plug in all the numbers here. I'm not gonna go over that. That's not the important part. The important part is setting up the equation. So we plug in the numbers, we get Vg2 in terms of Vg1. So we get Vg2 equals 0.8921 Vg1. Next, let's go over conservation of energy. We covered that in the previous video. So we have T1 plus V1 equals T2 plus V2. Now if you don't know this, you probably should go back to the previous video, cover that, and then come back here. So what's T1? 1/2 mv squared, and then B1 we have 1/2 omega 2 squared. Now at state 2, when the ball is over here, sorry, the wheel, the only thing we have is gravitational work, which is the weight times the distance. Now what's the weight? 98.1. What's the distance from the ground from the state before? 0.03. So we have here these two. And so we don't know what W2 is, but if you remember, omega equals V over R. Well, it comes from this. V equals R omega. So omega equals V over R equals V over 0.2. So equals 5B. So we plug in 5 Vg2 over here. We only have one unknown, which is Vg2. Plug in all the numbers and we get Vg2 equals 0.729 meters per second. Now this basically summarizes this chapter. Thank you everyone for listening.